In September 2014, one of the American satellites conducting routine measurements over Antarctica detected an unusual gravitational anomaly in the western part of the continent. At first, there seemed to be nothing extraordinary about it. Active volcanic regions beneath West Antarctica had been known for a long time. This part of the continent was very different from the ancient, billion-year-old rock mass of East Antarctica. The crust was thinner, fractured by old fault systems, and hot masses of rock were still moving several kilometers beneath the surface. But the structure detected in the new measurements was different. Deep beneath Marie Byrd Land, below several kilometers of ice and thick layers of rock, there was an extremely dense region. Magnetic readings suggested that it was not ordinary magma. Even stranger was the shape of the anomaly. The underground structure formed an almost continuous conductive line extending for hundreds of kilometers. A small team working with the United States Geological Survey checked the data again. They then examined 20 years of satellite records from the same region. The result did not change. There was an enormous geological structure beneath Antarctica that had never been identified before. At first, the discovery was supposed to be shared with the scientific community. But within a few months, the file was transferred to a different institution. The Department of Energy. Then the Department of Defense. And by early 2015, the entire investigation had been classified. The project was given the name Project Deep Echo. Officially, no such project had ever existed. The work planned in Antarctica was presented as a routine deep drilling program for climate research. But the real objective was not to study ice cores. The Americans wanted to understand what lay beneath the continent. In the summer of 2016, a new research facility was constructed roughly 1,000 kilometers from the South Pole. It was called Argus Station. From the outside, it looked no different from a small scientific base. There were several prefabricated buildings, communications antennas, generators, and heavy drilling machines positioned on the ice. But the main facility was not on the surface. Beneath the station were sealed laboratories excavated to a depth of nearly 40 meters. Most of the scientists working there did not know the full purpose of the project. Geologists studied only rock samples. Engineers were responsible for the drilling systems. Physicists were told they were working on an experimental system designed to measure electromagnetic conductivity deep beneath Antarctica. Fewer than 30 people understood the entire project. The first drilling operation had taken almost 3 years. Penetrating the ice sheet had been more difficult than expected. In some areas, the ice was constantly moving and slowly closing drilling shafts that had been opened only months earlier. Finally, in December 2018, the drill reached Antarctica's rocky bed. The ice was approximately 4,800 meters thick. But the drilling did not stop there. The team continued deeper into the rock. 500 meters. 1,000 meters. 1,800 meters. At a depth of roughly 2,300 meters, the sensors detected something unusual. Electrical conductivity suddenly increased by hundreds of times. At first, the team believed they had reached a large body of salty groundwater. But when rock samples were brought to the surface, they revealed a different picture. The samples contained unusually high concentrations of iron, nickel, and graphite-like carbon structures. Formed under extreme pressure, these minerals created natural conductive pathways through the rock. The calculations that followed were astonishing. The structure did not exist only beneath the drilling site. According to geophysical data, the same mineral layer extended for at least 800 kilometers. More importantly, it intersected much of the massive fractured region known as the West Antarctic Rift System. In other words, beneath Antarctica there was a naturally conductive network connecting ancient faults across the continent. The discovery completely changed the project. The goal was no longer simply to study the geological formation. The American research team began investigating whether the system could carry energy. In 2019, 9 additional drilling shafts were opened around Argus Station. Kilometers of electromagnetic sensors and high-powered coils were lowered into each shaft. In theory, the system was simple. Short electromagnetic pulses would be transmitted through the coils, pass through the rock layers, and be detected by sensors in the other boreholes. This would allow scientists to create a three-dimensional map of the structure beneath the continent. The method was often compared to magnetic resonance imaging. But the scale was entirely different. Instead of scanning the human body, they were scanning the crust of an entire continent. The first experiments were conducted at low power. The results were successful. Electromagnetic pulses traveled much farther than expected. But the scientists noticed something else. After the system was shut down, the sensors continued receiving a signal. At first, they thought it was an equipment malfunction. But the signal was regular. It repeated approximately every 12 minutes. More precise measurements showed that the interval was exactly 11 minutes and 42 seconds. Every 11 minutes and 42 seconds, a low-frequency electromagnetic pulse emerged from deep beneath Antarctica. The source of the signal could not be identified. After months of investigation, the research team developed a theory. The conductive mineral network beneath Antarctica might have been collecting fluctuations in Earth's natural electrical and magnetic fields. But that was not the only explanation. The region was also under constant tectonic stress. Immense pressure in the crust could produce electrical charges in certain rocks. The mechanism, known as the piezoelectric effect, was well understood on small scales. But here, the system extended across hundreds of kilometers. Some scientists proposed an even more speculative possibility. The mineral network deep beneath the continent might have been acting as a natural resonator, storing Antarctic tectonic stress in the form of electromagnetic and mechanical energy. At first, the idea was considered too speculative. But as the experiments continued, the theory began to receive more serious attention. By the middle of 2020, the project entered a new phase. The American government connected the research to a classified energy program. If the underground structure truly carried natural energy, perhaps that energy could be extracted in a controlled way. What lay beneath Antarctica might not have been an ordinary geothermal reserve. It could have been an enormous natural energy system continuously supplied by the planet's internal heat and tectonic movement. According to theoretical calculations, the energy available from even a small part of the structure could have rivaled the output of several large nuclear power plants. But not everyone agreed with the direction of the project. Several geophysicists warned that the behavior of the system was not sufficiently understood. The electromagnetic pulses might not have been merely imaging the underground environment. They might also have been amplifying natural vibrations within the crust. During an experiment in November 2020, a magnitude 3.1 earthquake occurred approximately 150 kilometers south of Argus Station. Earthquakes of that magnitude were not unheard of in Antarctica. But the timing was concerning. The tremor occurred exactly 38 minutes after the experiment had begun. 2 months later, it happened again. This time, the earthquake reached magnitude 3.4. Its epicenter was located roughly 200 kilometers from the previous event. The first serious objections to the project began at that point. Several scientists called for the experiments to be suspended. But the data revealed something else as well. After every experiment, the 11-minute and 42-second underground signal became stronger. That only increased the interest of the project's leadership. In 2021, the system's power was increased. New generators were transported to the station. A total of 18 electromagnetic stations were installed around Argus. The system was now capable of producing short energy pulses reaching hundreds of megawatts. The goal was to determine the full boundaries of the mineral network beneath the continent. During a major test in December, something unexpected happened. The transmitted signal was detected at another research station nearly 1,400 kilometers away. Technically, this should not have been possible. Under normal circumstances, the signal should have weakened after only a few hundred kilometers. Instead, the underground structure had carried it across the continent. At that point, the scientists finally understood the true scale of the system. The network did not exist only beneath Marie Byrd Land. It extended across much of West Antarctica. It probably connected ancient fault systems stretching from the Ross Sea to the Weddell Sea. That meant the system could have been nearly 3,000 kilometers long. In January 2022, a closed meeting was held in Washington to decide the future of the project. One group of scientists argued that all further testing should stop. Another group wanted several additional large-scale experiments. In the end, the second position was approved. The final experiment was scheduled for January 23, 2022. It would be more powerful than every previous test. All 18 stations surrounding Argus would operate simultaneously. Electromagnetic pulses would be transmitted for fractions of a second while scientists attempted to determine the resonance frequency of the mineral network below. The test began at 4:12 a.m. local time. The first 3 minutes were completely normal. Sensors recorded strong but expected readings. At 4:16 a.m., the natural underground signal began drifting toward the same frequency as the artificial electromagnetic pulses. Inside the control room, the researchers believed they were witnessing extraordinary data. Instead of stopping the experiment, the operators continued. At 4:18 a.m., the two signals completely synchronized. In later technical reports, this moment was described as phase locking. The artificial energy supplied by the experiment and the natural underground vibration had begun moving in the same rhythm. For several seconds, nothing happened. Then every sensor reached its maximum reading at the same time. Most of the screens in the control room shut down. 3 of the underground coils burned out because of excessive current. The team initiated an emergency shutdown. The generators were disconnected. But the signal did not stop. Instead, it continued growing. That was the moment the Americans understood their greatest mistake. The experiment had not created energy. It had activated a system that had already been there. The mineral network beneath the continent was not an energy source. It had behaved like a switch. Tectonic stress, deep geothermal heat, and high-pressure fluids that had accumulated beneath Antarctica over millions of years were all part of the same connected system. The electromagnetic experiment had disturbed its balance. At 4:23 a.m., the first major rupture occurred approximately 2 kilometers beneath Argus Station. A deep sound rose through the ice. At first, the people on the surface assumed it was ordinary ice cracking. Then the entire station began shaking. The tremor lasted roughly 40 seconds. It was later estimated at magnitude 5.6. 5 minutes later, a second earthquake struck. Then a third. At 4:41 a.m., all underground sensor contact was lost. Hot water and steam began rising from several boreholes. Fluids that had normally remained hundreds or thousands of meters below the surface were now being pushed upward by changing underground pressure. The station was evacuated. Most personnel were transported by snow vehicles and helicopters to an emergency landing zone nearly 100 kilometers away. But the real disaster was not happening at Argus Station. The energy was moving beneath the continent. Within 5 hours, seismic stations in Australia, Chile, and South Africa began detecting unusual vibrations coming from Antarctica. They did not resemble ordinary earthquake waves. The signals appeared intermittently and followed specific pathways beneath the continent. It was as if something underground was moving from one fault to another. On the evening of January 23, the first major rupture occurred near the Ross Sea. A new fault approximately 200 kilometers long opened beneath the ice sheet. Its effects became visible at the surface several hours later. Satellite images showed thin black lines stretching across hundreds of kilometers. At first, they were believed to be ordinary ice fractures. But by the following day, some of the cracks had widened to more than 100 meters. On the morning of January 24, the United States government classified all communications connected to the project. The world was told that Antarctica was experiencing an unusual natural earthquake sequence. But that explanation would not last long. The same day, European and Japanese satellites detected an extraordinary increase in heat beneath the continent. In some regions, geothermal heat flow had risen by nearly 40% within hours. The base of the ice sheet began melting rapidly. The melting was not immediately visible from the surface. Instead, thin layers of water formed beneath the ice. This reduced friction between the massive ice sheet and the bedrock beneath it. Several Antarctic glaciers began moving 3 to 4 times faster than normal within days. On January 25, a major subglacial discharge occurred beneath the Thwaites Glacier. Billions of tons of fresh water moved toward the sea. The same day, enormous sections of ice broke away near Pine Island. The largest was comparable in area to a small country. But those events were only the visible part of the disaster. The real changes were still taking place beneath the continent. The energy had moved eastward through the West Antarctic rift system. High-pressure hot fluids were forced into ancient fault zones. These fluids reduced friction between rock surfaces and caused faults that had remained locked for thousands of years to begin moving. In simple terms, Antarctica's underground geological system was beginning to unravel in a chain reaction. On the night of January 26, the largest earthquake struck. Its magnitude reached 7.9. The epicenter was deep in the interior of the continent, thousands of kilometers from any permanent settlement. But its effects were felt across the Southern Ocean. Small tsunamis reached the coasts of New Zealand and South America. Several research vessels around Antarctica reported unusual waves several meters high. Approximately 6 hours after the earthquake, satellite radar revealed something that had never been seen before. A massive fracture was extending inland from the Ross Sea. It was not only a crack in the ice. Radar measurements showed that the bedrock beneath it had also ruptured. At almost the same time, a second fracture was advancing from the direction of the Weddell Sea. A scenario that geologists had discussed only in theory for decades was now becoming reality. The ancient rift system beneath West Antarctica was being reactivated. Under normal conditions, such a process might have taken millions of years. But many of these faults had already been close to failure. The Deep Echo experiment had only pushed the first domino. On January 28, the two major fracture systems connected near the center of the continent. From that moment, the map of Antarctica began to change. In some regions, the bedrock dropped several meters. Elsewhere, sections of crust were pushed upward. The ice sheet fractured along thousands of kilometers of fault lines. Seawater began entering newly formed valleys deep inside the continent. This did not mean Antarctica had suddenly split into several separate continents. But something much more significant had happened geologically. The bedrock of West Antarctica had begun dividing into independent blocks. New marine channels were forming beneath what had once appeared to be a continuous ice-covered landmass. By the first week of February, a vast fracture corridor had formed between the Ross Sea and the Weddell Sea. In some areas, ocean water penetrated more than 100 kilometers inland. West Antarctica was beginning to lose its identity as a single continuous landmass. Dark networks of fractures were visible across the continent in satellite images. The largest ice mass on Earth was slowly breaking apart. And the process had not stopped. On February 3, 2022, the United States government was forced to brief several allied governments in secret. The United Kingdom, Australia, New Zealand, and Canada were given limited information about the experiment. But the true cause of the disaster was still withheld. Washington continued to claim that the catastrophe had resulted from an acceleration of natural tectonic processes. Other nations were conducting their own investigations. Russian and Chinese research stations had recorded powerful electromagnetic pulses coming from inside Antarctica on the morning of January 23. The pulses had begun several minutes before the first earthquakes. Such a signal was extremely unusual before a natural seismic event. In mid-February, Chinese researchers shared their data with the international scientific community. That was when the first suspicions about deep echo began to emerge. Investigators discovered that the United States had been transporting large quantities of equipment for years to a facility called Argus Station, a base that did not appear in public Antarctic records. Satellite images showed heavy generators and drilling systems at the site. Washington was forced to respond. The American government admitted that experimental geophysical research had been conducted in Antarctica but denied any connection between the experiments and the disaster. That explanation survived for only 4 days. On February 19, an engineer who had worked inside the project leaked approximately 600 gigabytes of classified data to the press. The files contained experiment logs, sensor measurements, internal warnings, and detailed information about the January 23 test. For the first time, the world learned what had really happened. The Antarctic disaster had not begun naturally. An American experiment had triggered it. The leak created an immediate political crisis. The United Nations Security Council held an emergency meeting. Countries that were parties to the Antarctic Treaty demanded that the United States release the full project records. Washington initially refused. But the disaster continued to grow. By March, average ice flow in West Antarctica was 5 times faster than before the crisis. In some regions, it was 10 times faster. The amount of ice reaching the ocean increased rapidly. During the first months, global sea level rise remained limited to only several centimeters. But climate models showed a much more dangerous future. A large part of the West Antarctic ice sheet had entered an irreversible state of instability. Processes once expected to take centuries could now occur within several decades. That meant long-term sea level rise measured in meters. From Miami to Shanghai, from Istanbul to Amsterdam, hundreds of coastal cities began preparing new evacuation and protection plans. But the climate effects were not limited to sea level rise. Enormous amounts of fresh water were entering the Southern Ocean. This began changing the density structure of the ocean. The cold, dense water formed around Antarctica played a major role in the deep circulation of the world's oceans. That circulation began to weaken. Weather patterns across the southern hemisphere shifted. Within several years, rainfall patterns in parts of Australia and South America were measurably different. But the signal beneath Antarctica remained the greatest concern. The 11-minute and 42-second electromagnetic pulse had not disappeared after the January 23 experiment. Instead, it began appearing in sensors across eastern parts of the continent as well. That suggested that the energy system was not limited to West Antarctica. Scientists began considering the possibility that conductive mineral networks might also exist beneath East Antarctica. If the same chain reaction reached the east, the consequences could be completely different. The volume of ice in West Antarctica was enormous. But East Antarctica was far larger. Most of Earth's frozen freshwater was located there. For that reason, an international scientific team deployed hundreds of new sensors around the continent in 2023. Their goal was to track the movement of underground energy. The United States also agreed for the first time to release all remaining deep echo records. After months of analysis, scientists largely reconstructed the mechanism behind the disaster. There had never been a single energy source beneath Antarctica. It was not, as newspapers had first suggested, an enormous natural nuclear reactor or an unknown form of matter. The reality was far more complex. Beneath West Antarctica, rising mantle heat, high-pressure underground water reservoirs, metal-rich rock layers, and ancient fault systems all intersected. Together they had created a geological structure that had accumulated tectonic stress for millions of years. Under normal conditions, that energy would have been released gradually through earthquakes and volcanic activity. But the electromagnetic pulses from deep echo had created resonance within the conductive mineral network. That resonance accelerated the movement of deep fluids and altered friction conditions along several faults. When one fault ruptured, stress was transferred to another. Then another. And another. Humanity had not produced enough energy to tear apart a continent. The energy required to do that would have exceeded the combined force of every nuclear weapon on Earth many times over. What humanity had done was much simpler. It had unlocked a geological system that was already under immense pressure. Like a tiny spark starting a massive forest fire. But one detail in the Deep Echo files prevented the controversy from ending. A report written in 2019 had clearly warned that the experiments could trigger large tectonic events. The probability had been considered low. But it had never been zero. More importantly, several internal reports written in 2020 and 2021 stated that the small earthquakes detected during earlier experiments might have been connected to the project. Despite those warnings, Deep Echo had continued. The reason eventually became clear. The American government did not view Deep Echo as purely scientific research. If the underground energy could be used in a controlled way, the United States might gain access to an almost limitless geothermal energy technology. More importantly, the same technology could eventually be used on other planets. On cold worlds such as Mars, extracting heat from deep beneath the surface could become essential for future colonies. Project leaders had accepted the risks. The result became one of the greatest scientific disasters in human history. By 2024, old maps of Antarctica were becoming obsolete. Dozens of ice shelves along the West Antarctic coast had collapsed. The fracture system between the Ross and Weddell Seas continued to expand. New marine channels had formed in several regions. Ocean water now flowed beneath valleys that had once been sealed under kilometers of ice. Geologists gave the region a new name. The Antarctic Rift Corridor. Although Antarctica was still shown as a single continent on maps, West Antarctica was increasingly becoming a geological archipelago. The rock blocks beneath the ice were separating from one another. The process could no longer be completely stopped. But the worst-case scenario had not occurred. When the energy chain reached the ancient craton of East Antarctica, it weakened dramatically. The billion-year-old rock beneath East Antarctica was far thicker and more stable than the fractured rift system in the west. By late 2024, the frequency of major earthquakes began to decrease. By the middle of 2025, the electromagnetic energy measured beneath Antarctica had fallen to approximately twice its pre-crisis level. Scientists began to believe that the system was moving toward a new equilibrium. But no one knew how long that would take. All 43 people working at Argus Station on January 23, 2022, had survived. The station itself disappeared several months later. The ice beneath the facility split apart, and the remains of Argus fell into a newly formed chasm almost 3 kilometers deep. The center of the Deep Echo experiment could no longer be reached. The region was now covered by moving ice blocks and open water channels. Years later, during an official investigation, the final director of the project gave a single statement. It summarized everything. Humanity had not discovered a new source of energy beneath Antarctica. It had simply touched a balance that should never have been disturbed. In the years following the disaster, all deep energy experiments in Antarctica were placed under international supervision. New agreements were signed. No country was permitted to conduct large-scale electromagnetic, nuclear, or geothermal experiments beneath the continent without international approval. Antarctica was no longer regarded only as a natural environment that needed protection. It was now treated as an enormous geological laboratory directly connected to the internal systems of the planet. But one detail remained unexplained. The 11-minute and 42-second signal recorded before the Deep Echo experiment was much older than the project itself. When researchers later examined analog magnetic records from the 1980s and 1990s, they found weak traces of the same frequency. In other words, the system beneath Antarctica had been vibrating long before humans discovered it. And the rhythm was not random. When the energy level increased, earthquake activity increased with it. When the energy decreased, the continent became quieter. Because of this, some geophysicists continue to discuss a disturbing possibility. Perhaps the Deep Echo disaster had never created anything new. Perhaps America had only started a natural geological cycle several centuries earlier than it would otherwise have begun. And if that was true, then the fragmentation of Antarctica was not a single disaster that started in 2022. It was the beginning of a much larger and much longer transformation of the Earth. In 2026, sensors around Antarctica were still recording the same signal. 11 minutes. 42 seconds. 11 minutes. 42 seconds. Each time, a very weak electromagnetic vibration rose from several kilometers beneath the continent. Most of the time, it remained unchanged. But in July 2026, 3 monitoring stations recorded a small increase on the same night. The rise was only 0.7%. Scientifically, it was not large enough to trigger an alarm. But no one who had studied the Deep Echo disaster ignored it. Because on the morning of January 23, 2022, everything had started in almost exactly the same way. First, a small signal. Then resonance. Then an earthquake. And within days, one of the largest continents on Earth had begun breaking apart before the world's eyes. Antarctica still appeared white and silent on maps. But no one believed it was truly silent anymore. Kilometers beneath the ice, faults were moving. Hot water was flowing through fractures in the rock. Energy from deep inside the planet was slowly moving toward the surface. Perhaps that was the greatest legacy of Deep Echo. Humanity had finally understood how powerful the Earth truly was. Modern machines, satellites, and computers had allowed us to study the deepest systems of the planet. But that did not mean we could control them. The Antarctic disaster had not been caused by a weapon. It had not been caused by a war. And it had not begun because a group of people wanted to destroy the world. Quite the opposite. It had begun with an experiment conducted by people who wanted to understand the planet more deeply and discover a new source of energy. And perhaps that was the most disturbing part of the entire disaster. Because many of the most dangerous experiments in history had not begun with malicious intentions. They had begun when someone crossed a boundary before understanding how far they had already gone. In Antarctica, that boundary had been crossed on the morning of January 23, 2022. And the fractures opened that day were not only inside the ice and the rock. They had also opened inside humanity's faith in its own technology.